Welcome to this class, and here we're going to do more examples on how to apply quadratic equations. We have a triangle here whose dimensions are as follows: x minus 2, x minus 3, and the hypotenuse is given as x. We are supposed to find the area of this triangle. How do we go about it? Now we know one thing. For us to be able to find the area of this triangle, which is going to be, of course, a half base times height, we must find the values of x first. The moment we get the value of x, then we can go ahead and find the area of the triangle. So for us to find the area of the triangle, we are going to find the values of x, and we can use the concept of the Pythagoras theorem, that if this side is given as a, this as b, and this as c, it means that if we take a squared plus b squared, we must get c squared. And therefore, it means if we take x minus 2 squared, we multiply by, we add to x minus 3 squared, we must get x squared. So our task will be to expand each of these. Now, for us to expand this one, then we're going to have, to expand the left hand side, then we're going to have x squared minus 4x, that is an identity of expansion, minus or plus 4. Plus, now if you expand this, you're going to get x squared minus, now this is going to be 6x minus 9 plus 9, that is equals to x squared. And this is these are identities I just used. If you have x or a, you have a minus b squared, that can be written as a squared minus ab twice ab, that is 2ab, minus or plus the last term squared. So those are the ones that I just used here. We are going to collect like terms together. We're going to have, of course, this is going to cancel out with the one on the other side, and therefore we're going to remain with x squared. We're going to have a minus 10x, because a minus 4, a minus 6x is a minus 10, and then we're going to have 4 plus 9, that is going to be 13, is equals to 0. Okay, so we have a quadratic equation which we need to solve for values of x. The easiest way to solve a quadratic equation is by use of quadratic formula, that x is equals to negative b plus or minus the square root of b squared minus 4ac. We divide by 2a. The value of a here in our quadratic equation is 1, b is given as negative 10, and c is given as 13. So let us solve. So x can be given by negative b, that is minus into negative 10, plus or minus the square root of b squared, that is negative 10 squared, minus 4 multiplied by a, 1 multiplied by c, 13. All this will divide by 2 multiplied by 1. So let me grab my calculator here, very quick. So here we're going to have 100. We're going to have 100. So x is going to be equal to, this is going to be a positive 10 plus or minus 100 minus 13 multiplied by 4. That is 13 multiplied by 4 is 22. 100 minus that one is 48. So we're going to have the square root of 48 divided by 2. So we're going to find the first value when it's a positive, and the second value when it's a negative. X is equals to, so that is root 48. We add to 10 and divide by 2. That is going to be 8.4 or 8.5, approximately 8.5. And the second value is going to be root of 48. And then minus 10 minus the answer, divided by 2. So x is equals to 1.5. 1.5. So we have two values of x, 8.5 and 1.5. So what we need to do, we're going to find two possible areas, because we can replace these values by x right here. So the first value with the first possible area is going to be equal to, first of all, we can have the triangle. So the triangle is going to have the following dimensions. So 8.5, the first one is going to be 8.5 minus 2, that is 6.5, and 8.5 minus 3 is 5.5, and this is 8.5. So area can be found as a half times base 5.5 times height 6.5. That is the first possible area, and the second one is going to be equal. So we need to say or here. So 1.5 minus 3. Oh, it's a negative 1.5. Remember, we cannot have negative dimensions, and therefore we are going to ignore this and take this as the correct value of x for our triangle. In this case, when we are looking for the area. Right. So if you have this as a 5.5 multiplied by 6.5, we divide that by 2, then the area is equals to exactly 17.875 centimeters squared, if the unit are in centimeter. So that's how we do it. Remember, this is an application of quadratic equation. We had to incorporate the concept of Pythagoras theorem, where we say a squared and b squared equals to c squared, for us to be able to form a quadratic equation, which we also use the quadratic formula to solve for the values of x, and thereafter we had to finish by answering the question, the area of the triangle. And that's how we do it.